Hi, today we're going to be looking at 7.2 compound angle formulas. The goal for today is to verify and use compound angle formulas. And this comes on the heels of us working on 7.1, which is exploring equivalent trigonometric functions, where we were identifying equivalent trigonometric relationships. The reason why we're going to be learning about compound angle formulas is to find the sine, cos, and tan ratios of angles that are not special angles. Okay, so let's take a look at a couple of these angles and these trig ratios. So from the past experience, we know that sine of pi by 6 using our special triangles is 1 over 2, and sine of pi by 3 is root 3 over 2. Therefore, sine of pi by 6 plus sine of pi by 3 would be 1 over 2 plus root 3 over 2, which equals 1 plus root 3 all over 2. Okay, so then if we look at this in a different way, we see that sine of pi by 6 plus pi by 3, if we were to add these two angles together, we see that it would be sine of pi by 2. And then from the sine ratio, we see that sine of pi by 2 is 1. Here we see that the sine of pi by 6 plus pi by 3 is 1, and the sine of pi by 6 plus sine of pi by 3 is 1 plus root 3 over 2. Therefore, these two things are actually not equal to each other. So what we need to do to deal with issues like this is we need to come up with a compound angle formula to deal with these compound angles. What I'd like you to do now is go to the class portal and check the PowerPoint presentation, which is to show how these compound angle formulas are actually derived. Okay, so pause the video please and check out that PowerPoint presentation. Okay, so that looked easy enough, I hope. So now if we take a look at, we'll just fill in these formulas here. We see that the compound angle formula for sine, when we have sine of an angle plus a different angle, the formula is sine A cos B plus cos A sine B. Okay? Cos of negative theta is cos theta from the cast rule, and sine of negative theta is negative sine theta, again from the cast rule. Being that if this is a negative angle, then the angle would go down into the fourth quadrant, where only cosine is positive and sine is negative. Now if we were to substitute negative b in for b in the original formula here, then the formula would then become sine A cos B minus cos A sine B. Okay, so basically the same thing, no big difference there. Now if we're going to go to the compound angle formula for cosine, we can develop that sort of the same way as you saw in the PowerPoint presentation, and the final formula would be cos A cos B minus sine A sine B. And then by replacing b with negative b, we get cos A cos B plus sine A sine B. Now, we don't just get to enjoy sine and cosine, we also get to look at the tangent ratio. So we know that tan A plus B, or tan theta, is sine theta over cos theta. So tan of A plus B is sine A plus B over cos A plus B. And sine of A plus B is sine A cos B plus cos A sine B from page 1 of this lesson. And cos A plus B is cos A cos B minus sine A sine B from the first page of this lesson. And then if we divide the numerator and denominator by cos A cos B. Then what we're going to find is we'll put cos A cos B underneath each of those terms, and we can do a little bit of simplification, and we end up getting something like tan A plus tan B over 1 minus tan A times tan B. And now if we're to replace the B with a negative B to get the subtraction formula, we know, of course, also with a negative angle, this angle would drop into the fourth quadrant where tan is negative, using the CAS rule. So tan A minus tan B would be tan A minus tan B over 1 plus tan A times tan B. Okay, so there are 6 formulas that you have, 2 for sine, 2 for cos, and 2 for tan, and we're going to be using those to find expressions for compound angles. Okay, so just to warm ourselves up here a little bit, we want to express each angle as a compound angle using a pair of angles from special triangles. So 15 degrees is, we've got 45, 30, 60 degree angles. We've even got the 90 degree angle. We can use any combination of those to find 15 degrees by using any kind of sum or difference of those special angles. So what 2 angles would give you 15 degrees? Think about that for a second and come on back to check. Okay, so now that you've had a chance to think about that, we see that 15 degrees can be made up of a couple different options. We could either have 45 degrees minus 30 degrees, or it could be 60 degrees minus 45 degrees. For 75 degrees, we can do the same kind of thing. Think about that for a second. And we see that that can be made up of 45 degrees plus 30 degrees. And 5 pi by 12. The ratings are a little bit more challenging, but still, of course, doable. 5 pi by 12. We want to use 2 special angles to make up 5 pi by 12. So we've got pi by 4, pi by 6, pi by 3, and pi by 2 that we could use. So if we add these together, we get 3 pi by 12 plus 2 pi by 12. Obviously that makes up 5 pi by 12. And then we can reduce these down to get pi by 4 plus pi by 6. And then those are the special angles we can use.